The James Webb Space Telescope has once again opened a breathtaking window into the cosmos. Its unprecedented sensitivity and cutting-edge infrared capabilities have allowed scientists to peer deeper into space than ever before. Now, it has revealed one of the most promising discoveries in recent memory, a highly habitable super-Earth, located just 40 light-years away in the TRAPPIST-1 system. This finding doesn't just stir excitement, it reshapes our understanding of habitability, life, and our place in the universe. This super-Earth is larger than our planet, yet smaller than gas giants like Neptune. It lies within its star's habitable zone, the region where temperatures may allow liquid water to exist. On Earth, where there is water, there is life. So, this seemingly ordinary planetary detection may very well be our strongest candidate yet in the search for extraterrestrial life. But what exactly is a super-Earth? Despite its name, a super-Earth doesn't necessarily imply that the planet is like Earth, only bigger. Rather, it's a class of exoplanet that is rocky in composition and typically has a mass between 1 and 10 times that of Earth. These planets are rare in our own solar system but are surprisingly common throughout the galaxy. With stronger gravity, thicker atmospheres, and dynamic geological activity, they might even be better suited for life than Earth itself. Thanks to Webb's advanced spectroscopic instruments, scientists have detected water vapor, methane, and oxygen in the atmosphere of this particular super-Earth. These chemicals are not just common, they are essential for life as we know it. On Earth, their presence in an atmosphere is usually associated with biological processes. Their detection on this distant world sets off a chain of profound scientific questions. Are we witnessing the chemical fingerprints of alien biology? This discovery also enhances our understanding of how planetary systems form and evolve. The TRAPPIST-1 system, centered around an ultra-cool dwarf star, hosts 7 rocky planets, 3 of which sit in the habitable zone. The system has been a source of fascination since its discovery, but now, this super-Earth has taken center stage. TRAPPIST-1's cool and stable nature provides a relatively calm environment compared to more volatile stars, reducing the potential damage caused by intense radiation and stellar flares. This stability makes the presence of complex atmospheric chemistry all the more intriguing. However, this exoplanet's proximity to its star creates a curious condition, tidal locking. One side of the planet always faces the star, basking in constant daylight, while the other side is trapped in endless darkness. At first glance, this might seem to eliminate the potential for habitability. But scientists propose a fascinating solution. The planet's dense atmosphere could act as a global heat redistributor, transferring warmth from the star-facing side to the dark hemisphere. This mechanism could result in a temperate band along the terminator line, the boundary where day meets night, possibly offering the perfect region for life to thrive. And then comes perhaps the most exciting aspect, biosignatures. Scientists are not only detecting chemicals like methane and carbon dioxide, but also analyzing their ratios and fluctuations, clues that could differentiate between geologic and biologic origins. On Earth, seasonal changes in atmospheric composition are driven largely by life. If similar changes are observed here, it could be the strongest indicator yet that life exists beyond our world. Water is often called the essence of life, and in this discovery, it plays a central role. Webb's observations revealed compelling signs of water vapor, hinting at the presence of liquid oceans. And if surface temperatures prove too extreme, scientists believe that underground aquifers, protected from solar radiation and insulated from freezing temperatures, could provide havens for microbial life, much like the extremophiles found in Earth's deep caves and hydrothermal vents. The possibility of life beneath the surface, surviving under thick ice or within deep rock fissures, is no longer science fiction. In fact, Earth offers similar environments, such as the ecosystems that thrive beneath Antarctica's subglacial lakes or within deep oceanic crusts. These comparisons allow scientists to draw realistic models of how life could persist even in alien environments. The James Webb Space Telescope is the reason we know all this. By capturing faint infrared light that has traveled for tens of light years, Webb can analyze the atmospheric composition of planets orbiting distant stars. Using transit spectroscopy, it observes the light from a star as it passes through a planet's atmosphere, identifying unique spectral fingerprints of gases. In this case, water, methane, oxygen, and even carbon dioxide were clearly detected. But this is only the beginning. As more data pours in, scientists will look for temporal variations in these gases. For example, an increase in oxygen during a planet's spring, and a decline during fall, if such cycles exist, would suggest biological rhythms not unlike those seen on Earth. And what about the potential inhabitants of this world? That's where things become truly speculative and truly fascinating. Due to high gravity, any surface-dwelling life forms might be shorter and more muscular to support their own weight. The thick atmosphere could create low light conditions, possibly leading to creatures with enhanced visual or sensory adaptations. If life exists in the oceans, it might resemble Earth's early microbial forms, or perhaps something far more advanced, adapted to tides, darkness, and chemical energy. Some researchers imagine giant photosynthetic organisms floating in perpetual sunlight on the day side. Others speculate about deep-sea-like beings in subsurface oceans. There could even be forms of life so foreign to us that we might not immediately recognize them as living at all. Every piece of data from Webb provides insight not just into the existence of life, but into the infinite diversity it might take. Now comes a difficult but important question. If we detect intelligent life, should we attempt to make contact? This debate has been raging in the scientific community for decades. Optimists argue that a conversation with a more advanced civilization could unlock knowledge that would revolutionize humanity. But cautionary voices, including those of physicists like Michio Kaku, warn that making ourselves known might invite attention we're not prepared for. After all, we have no way of knowing whether such civilizations are peaceful or predatory. The implications are vast. Would contact uplift us, or endanger us? Webb's discoveries bring these questions to the forefront in a way that's no longer hypothetical. We are peering into the homes of other worlds, and we may soon find that someone is looking back. Beyond the philosophical and ethical implications, there is also the technological challenge. At 40 light-years away, this super-Earth is far beyond the reach of our current spacecraft. Even our fastest probes would take tens of thousands of years to arrive. But exciting concepts are emerging, like laser-driven light sails, fusion engines, and interstellar microprobes. Initiatives like Breakthrough Starshot propose sending tiny spacecrafts traveling at 20% the speed of light, reaching nearby stars in just a couple of decades. In the meantime, Earth-based research is accelerating. Scientists are using machine learning and AI to sift through massive datasets from Webb, discovering patterns invisible to the human eye. These analyses can reveal subtle details about atmospheric pressure, surface composition, and weather patterns on distant worlds. Future space telescopes, like LUVOIR or Habitable, will build upon Webb's discoveries and might even provide direct imaging of exoplanets, perhaps offering us the first real glimpse of an alien landscape. This discovery also has profound effects on public interest. Space agencies around the world are reporting increased funding, and private companies are investing heavily in exoplanet research. Humanity's curiosity is reignited. The idea that we might soon confirm the existence of alien life is no longer just a dream, it is becoming a tangible reality. As we move forward, the search for biosignatures continues to guide scientific exploration. Molecules like nitrous oxide, often overlooked, are now considered key indicators of life, especially if found alongside methane and oxygen. Scientists are also examining how stellar activity, planetary magnetic fields, and tectonic activity contribute to a planet's long-term habitability. And finally, we must consider the bigger picture. The discovery of this habitable super-Earth is not just about one planet, it's about what it represents. It suggests that life may be common, not rare. That the conditions for biology might emerge wherever the environment allows. And that the universe may be teeming with life, waiting to be found. This is not the end of the story. It's only the beginning. As we gather more data, develop faster spacecraft, and build more powerful telescopes, we edge closer to answering the most profound question of all time. Are we alone? And if not, who, or what, is out there? If this journey through space and possibility inspired you, then join us here on Discovery at 2.0. Subscribe to the channel, tap the notification bell, and stay with us as we continue exploring the wonders of the cosmos, one discovery at a time. Thank you for watching. And remember, the stars are not the limit, they're just the beginning.